There you go. Okay, that's what I highlighted. Okay? So we want to look at corresponding parts of triangles and also other polygons. If all the corresponding parts are congruent, then the polygons are going to be congruent to each other. Okay, so here's two examples, or an example, where we have triangle ABC is congruent to EFG.
Oh, I don't like this.
No, it's going to be fine. It's going to be fine, Mia. We're going to love this. Okay. Now, the order of the letters for the first triangle does not matter, but the second one, the vertices must correspond in the same order. Okay? So, for example, I could also say triangle CAB. Okay? So, it doesn't matter. I can name the first triangle however I like, but if I switch the orders, GEF. Okay?
Oh.
So it just needs to be the same.
Yeah. This is what we call a congruent statement. Okay? So if I ask you for a congruent statement, I'm asking for what two polygons are congruent to each other. Okay, and again, it doesn't matter what order you put the first one in. The second one has to have the same order of the letters. Okay? Now, if I know that the two triangles are congruent, we can just look at the order of the letters. So, for example, angle A, without even looking at the picture, angle A has to be the same as angle E. Also, I could do segment AB, like if I took the first two letters, would be congruent to segment EF. Yeah.
What is the order?
Yeah.
Like, as long as the order is the same on
Yeah.
like
What?
left off. Right?
Yeah.
What if the E, like, it's the exact same triangle and everything, it just flipped?
That's okay. They don't have to be drawn the same way.
So will it still be like A and E?
Mm-hmm. Okay, so
Your cat was like, no.
So angle A and angle E are congruent. Angle B and angle F are congruent. Angle C and angle G are congruent. Okay? All right, now AB is congruent to EF. We have BC. Oh, so I'm just looking at the order of the letters. So like AB are the first two letters. So it has to match EF, which are the first two letters. BC are the second two letters. And then AC or C has to be congruent too.
And G.
EG.
Whoa. Oh, never mind. I thought it said LG, but it just said G. Wait a minute.
Okay, I'm not going anywhere.
Stop.
Run away.
So definition of congruent triangles. These are two triangles whose corresponding parts are all congruent. Now, most of this chapter,
Yes.
not quite the definition, but like the congruent statement. Yeah, like you just have to put the letters in the right order.
There's a quiz tomorrow.
Oh my god.
All right, let's do. Yes, Maya.
Yes.
Over like this chapter, can you give a rundown of like what we should be expecting on the quiz?
Yeah, I have a practice quiz.
Okay.
Oh, yeah.
All right, third angles theorem. If we know two angles of one triangle are congruent to two angles of a second triangle, so if these two are congruent to these two, the third ones have to be. Why?
Because it adds up to 180.
Adds up to 180.
Is that not just the congruent? Isn't that already theorem we have? If one angle is congruent to another angle.
We did not do this with triangles, though.
Oh, because that's if this is.
Yeah, okay. All the stuff that we're doing in this chapter are going to be about triangles. So-
what are you saying? If C and K are congruent and B and J are congruent, then A and L have to be
Yeah.
congruent?
So basically like the segment theorem, but just like
So my conclusion, so therefore, angle A has to be congruent to angle L. Again, that would just be our third angle. The 3 dots are therefore. It's my abbreviation for that.
Yeah, I use that.
I don't.
This is a common abbreviation. If you use it in any math class, that will be fine. Okay. Okay. So this basically says if two triangles are congruent. Oh, my shoe. Did you hear something? Now, guys, come on. My shoe. Yeah. Yeah, we know how that goes.
Guys, I honestly
It's like
love
my
math
son at
classes.
home. He'll be like, "Oh, it's the chair." Oh, yeah, chair.
Yeah, and then it starts stinking up the whole room.
Oh my gosh.
No, but guys, like I loved my math class last year and this year.
You would even tell it.
What?
It's fine. It's fine. Okay, if two triangles are congruent,
No, like I'm saying, like I like math classes and they're fun.
Yeah, all math classes are
Like
fun.
this one's so
They'd be false. We
fun.
kept going. False accusation.
Bro,
Okay.
math class last year is so fun.
so if two triangles are congruent, then their parts are congruent. So we use an abbreviation because it could be a mouthful. So corresponding, here we go. Corresponding parts. Okay, corresponding parts just mean matching parts of congruent triangles are congruent. So, okay.
Do we have a proof we can use? Wait, is that like
Yeah, we're going to use this.
Another
We're going to use this a lot in proof. Okay.
Why do I have to memorize? Wait, we have to know
Guys,
this.
let's all stay.
We have to know this.
Okay, guys are a little overreacting, Sammy. We don't need to worry about memorizing anything at the moment. All you need to know is read triangle ABC is congruent to PQR. Okay, let's just say I know that. Then I know for sure angle A and angle P have to be congruent. They're the
Wasn't
first.
that just the last one?
But can it be that for any of them? Like,
Yeah.
why is it?
It's
That
just
was literally this.
This is just an
That
example.
was literally this.
Yes, but that was proving that. So that was they were already giving us congruent triangles, or they like the picture. This is saying here.
Wow, that was the exact same thing.
No, I know, but we're
You're
gonna.
doing the triangle again.
Yeah, but I'm just introducing. Like this is the formal reason why.
Okay. AC, F, and D, F, B. ACF.
Too much going on. Okay, angle A. If I start with angle A, I have to start with angle
So I said ACF.
D, B, F. Okay, again, the first one, it does not matter what order I put it in, but the second one has to be matching. Okay, corresponding angles. So I have angle A is congruent to angle D, C and B. But, okay, I cannot just say angle F because there are multiple angles here. So I have to be very specific. I have to say, like, this angle would be angle AFC would be congruent to DFB. Yeah, so you're writing all three corresponding angles. So if there's more than one angle at a particular vertex, we have to use the 3 letters. Okay, corresponding sides. So what do we see?
ACDB.
Well, AC, yep, and DB. We have FA and FB. Ooh. And CF and DF. Again, we know the segments can be turned backwards. It doesn't matter.
Segment B. CF and FB.
Yep, that's good.
Wait, hold on. I'm not gonna.
That's okay. It's okay.
Wait, whoa, what is
Well, again, you can look at the picture, or you, like these two segments are equal. Or sorry, these two are equal. These two are equal. These two are equal.
Huh?
Well, just look at the
I
markings.
put AF and DF.
Yeah. Oh, did I do the wrong ones?
No.
Oh, you're right. You're right. CF and FB. Sorry.
Wait, but
Sorry,
no.
it's these two are
Okay.
congruent and these
Yes.
two are congruent.
Yes.
Okay.
Whoa.
Wait, what was FB?
Sorry, these two were congruent. Yeah, these two and these two. Sorry. Okay, the next triangles. So the first one, it doesn't matter.
TJ.
HTJ.
No, that's like so. No.
Doesn't matter which way you
I did
say.
No. Okay, so it doesn't matter. HTJ. But I have to make sure what's happening here is the triangle, these two triangles are like switched upside down.
Instead of H, it would be T.
T. H.
TH.
K. Good.
Wait, you have to do it like a certain way.
Well, listen, if you put your order of your letters like this, you have to do this one. But you can have the first one switched around however you want.
Why is it upside down? Why
Just a
are
minute,
these
just a minute, just a minute. For example, J is where the right angle is. So I better make sure if J is the last letter here, K is the last letter here. Basically, what you have are alternate interior angles, like these would be congruent. And these would be congruent because the triangles are flipped upside down. HJT and TKH is fine.
Wait, but why are H and T supposed to be switched?
Because
It's flipped upside down.
No, it actually makes sense.
If you were to cut out this triangle and this one, and you want them to match, you'd have to flip one upside down. Okay.
Why does that matter if it's the same? Like,
No,
it's
no
no matter what.
okay.
Like, if
Let's
it's
say I
separate,
wanna
no matter
do
what
this.
it is,
Okay.
it's still the same
Let's say J and K. J is a right angle, and K is
No.
also a right
Okay.
angle.
So corresponding angles, we could do JHT.
Yeah, but it's not in between the J and the
Okay,
K.
questions,
This
guys?
is 90. This is
Why
90.
start
so
at
it's
H
congruent.
on the first one,
This is
and then
split,
start
and
at
this is
C on the
split.
second one?
Yeah.
Okay. If you're paying attention.
Ask us.
We talked about this already.
I'm still confused.
You have to go in like the same order, but you're starting top right.
I know, but the two triangles,
Oh, you rotate it.
you have to rotate it. So this, if I were to cut this out and paste it on top of this one, I would have to like rotate it around upside down. Okay. All right. So JHT has to be congruent to angle HTK. Okay. Oops, I didn't mean to put another congruent. So this angle, guys, this angle and this angle are congruent to each other. I also labeled them. Okay, I can't just say angle H congruent to angle T because there's multiple angles at those points. Just JHT, HTK, or you could do KTH. It doesn't matter as long as the vertex is in the middle. Okay. There could be HTJ. is congruent to KHT. And then finally, angle J is congruent to angle K. Since there's only one angle at each of those vertices, I can just put the letter. Okay, the sides are a lot easier. Okay, so HK is congruent to JT. JH is congruent to TK. Now, the last side happens to be a shared side. Okay? So this will be, you could say TH congruent to TH. This is actually where the reflexive property will come in. So anytime two triangles share a side, we count that as a pair of corresponding sides that are congruent. So again, you always need 3 pairs of angles and 3 pairs of sides in order for the triangles to be congruent.
This is a long
Yeah, you always need 2 pairs of angles and 2 pairs of sides.
Yeah. Okay, so
Why does it say congruent to TH?
so that's the third, because that's the third side that they both share.
Oh.
Okay? All right, let's take a look at,
Wow, that one was a hard one.
okay, so DE is congruent to EG. Given. DF is congruent to GF. Angle D is congruent to angle G. And these 2 angles are congruent. Okay, so far we have a pair of angles here, or sorry, pair of sides. We have a pair of sides, a pair of sides, a pair of angles, a pair of angles. So I need one more pair of sides and one more, right? I need 3 and 3. EF congruent to EF. Reflexive.
But how do we know this? Like, why can you say that?
This REF, what's reflexive again?
When it's congruent to itself.
It's
But
REF.
why?
Okay. So now I have listed, because whenever we're proving triangles congruent, we need to have all 3 pairs of sides listed, even including the reflexive one. I need all 3 pairs of angles. So I have 3 sides. Now I need to get my third angle. Yeah.
Why can we say that EF is congruent to EF? Like, you can just say that and it'll be okay.
Well, because it's the same thing.
I wasn't, like, I don't know if you said this, but why would you do S and A?
Oh, side, 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 angle, angle, angle. I just put it, you don't have to do that. I'm just trying to show you need 3 and 3. Okay, what's the reason why these 2 angles are congruent? No, we just did it. It's on the first page of the notes.
Oh, congruent. CASC. CPCTC. Third angle thing.
So if you have 2 pairs of angles congruent, the third's one. So
Third.
okay.
Yeah.
So why are they congruent? Definition.
I thought it was trans.
I thought it was
No, so we're trying to, the only way that we can prove triangles are congruent are definition of congruent triangles.
Third angle
That's
is
actually
always
a really
like.
smart
If you already know 2 angles,
CPCTC. It will always like be the CP. It will always be like third one.
Mhm.
Is it that way? Okay, this one.
okay.
You see? CPCTC. You didn't yell it.
All right, triangle
CPC.
ITP is congruent to NGO. So I want to find the values of X and Y.
I won the last video.
75.
Okay,
This is G.
what is, I'm actually going to solve for Y first. So looking at the order of the letters, angle O is the last letter in this triangle. So it has to match which one? P. So I'm going to make, perfect. So we're going to add 14 and divide by 6 so we get
Y
9. Good. So now I want to figure out
can we do
X.
TI?
minus 2y.
I have a question.
So what's NG? NG are the first two letters here.
And TI.
And IT or TI, which is right here. So we're going to set this equal to 7.5. Now, if I didn't have y, we would have had to have solved that first. But now,
No, but 2 times 9.
now I know that. So times 9. So x minus 18 equals 7.5. Good. You need me to go up? Okay. JKL is congruent to DEF. And then we're given some measures. So let's do part A, draw and label. Just draw two generic triangles. You could try to make them look somewhat the same. So if I label this JKL, DEF, okay, now we want to just label.
J equals 36.
Okay, and we also want to mark them congruent. So I'm just going to go through here real quickly. I'm going to make J and D congruent, K and E, L and F, and then I'm going to make JK congruent to DE, KL and EF, JL and D.
36.
Okay, now we can label, because what are we trying to figure out?
64.
Yeah, so if J is 36 and E is 64 and angle X is 3X plus 52.
Wait, can we do 36 plus 64 plus 3x plus 52 equals 180?
We can do that.
Just all of them equal 180.
36 plus 64 plus 3X plus 52. Yeah, because if they're congruent,
3x
right?
plus.
There's also another way we could have found this. If you know these two angles add up to 100, what's the missing angle measure have to be? 80. So we could also
Wait,
set.
that's actually so much easier.
Oh, but it doesn't really matter. It's gonna end up being the same amount of work, but if oh, you want to subtract that?
3x equals 28. 138. And 28. X equals 9.
Yeah, just leave it as 28 over 3. It's fine. You could just leave it.
The number one thing they taught us was to never have an improper fraction.
Oh, and then when you get to high school,
No, when you get to middle school.
everything is going to be improper fractions.
You're supposed to simplify everything. That is all.
Well, this is where this technically is simplified.
Yeah.
It's not just it's not a mixed number.
That's not.
We don't want it as a mixed number.
I like this one. I just thought
It's actually easier, and this is the way that you're going to leave more of your answers.
It takes too much work to make a mixed number.
I like in like when I was
Sammy,
in
you're still
algebra,
writing?
Like, we did not do like any like simple parallels.
Oh my god.
What do I have? Wait, look, you have this funny though. Oh my god, do I not have biology today?
No,
Wow,
we
this
don't.
is my
The
day.
test
This
is
is my
tomorrow.
favorite day.
Except we have a test tomorrow.
Okay, here we go. We're still recording. So,
Recording?
Oh,
It's
okay.
Sorry,
Yeah.
Justin.
okay, AB is parallel to CD,
I said that's suggested in biology.
Oh.
and AB. Okay, okay. We want to try to get the two triangles to be congruent. So far we just have one pair of sides.
We have all three sides.
Okay.
The midpoint of the
Ah, okay, so if E is the midpoint of AD, what is congruent?
A and E.
Okay,
Midpoint.
good.
Aren't they the same?
What else are congruent? It's also the midpoint of BC.
Which is why we should do BE. It's congruent to EC. Oh yeah, BE is congruent to EC and do that all in one step.
Yeah, we could do that all in one step. So E is the midpoint of both of those segments that make that X. So, okay, so we have all three sides. Now we want to do the three angles. I don't have any angles marked congruent yet. But we have parallel lines.
CD. Wait, can't we use them?
How about angle A? What are A and D?
They're alternate interior.
Okay, so angle A. So alternate interior angles theorem.
So is C and B.
So are C and B.
Wait, what did you just write? Oh yeah,
Okay. Now, we need one more pair of angles. We could make the
Vertical angle.
vertical angles.
So angle AEB.
Angle AEB.
Is congruent to angle CEB.
So that is vertical angles theorem. Okay, so do I have all three sides and all three angles now?
So that's the
One, two, three segments that are congruent. 1, 2, 3 angles. So we're good.
So now the definition of
Good. Triangle ABE.
how did all
Which ones?